Bismillahirrahmanirrahim. Assalamu alaikum viewers. How are you? Hope enjoying my lectures and enjoying your studies as well. Today, what was our topic? And it was, I told you that it was indices, which is the plural of index. Well, we are going to this book. We are going through this book. You have already been knowing and you have already been studying this with me for quite a while. Now, dear students, what are the index? Index, or it is singular and the plural to it is indices. This is singular. Let us start some English lecture, and this is plural. So, and index or indices can be interchangeably used by the word power or powers. These are one and the same thing. If I write here x raised to power n, x raised to power n, this means that here this thing is base and the thing which is superscripted. What is in computer you say it superscripted, and if it is written in here it is known as subscript. It is superscript, so I don't have to use subscript. This is superscripted, so it is power or index. This is power or index. Now there are some laws for power and indices and bases as well. Suppose when I say, I have already told you that if the bases are same and they are being multiplied, the powers are added together. Let me demonstrate it to you here. Power, index, and there is still one word left which I have not told you, is exponent. Exponent is mostly used in physics. In subcontinent, power is used for mathematics. For IGCSE, the word which is used is index. In physics, you might have noticed that something which were written like this into 10 raised to power 8. Now this is an exponential form. Now let me discuss about the laws of indices. Laws of indices are that if the bases are same and they are being multiplied together. For example, 2 multiplied by 2 multiplied by 2 multiplied by 2. What does it mean? That each 2 is superscripted with power 1 or index 1. Now what you have to do is you count 1 2 3 4. You'll write 1 out 2 out of all 4 or whatsoever they are in number. You count 1 2 3 4, and in fact what is being done here is like this, and it will become 2 raised to power 4. Or if there are one or two powers which differ like this, now you can do it 1, 2, 3, 4, 5, 6 like this. Just add them 3, 4, 5, 6. Now it will become 6 instead of 4. So this was the first law. Let me write it in the variable form. So if there is an x which is being multiplied by other x and other x, let me write the symbol with another color, and the power with yet another color, then it means that what you have to do is you have to write it 1, 2, 3. Okay, so this was the first law of indices. If we have just in the, like in this case, there was a 2 which was superscripted by 3. Now if it is superscripted by like this, if we have x square multiplied by x3, now this is multiplied. So what will we do, that we'll again add the indices and to give the answer as x5. Now let me write the same in the journal form. The same in the journal form. If bases are same, indices are different, or even they are same as well, like up till here or here. You say bases are same, indices are same, or if the bases are still same, the indices are different, then what will happen over here? We'll give this notation as xm plus n. xm plus n. So here it is only possible when the bases are same. When the bases are same. And you know what is a base? Let me tell you again that whatsoever is written here on the line, now this is the base, this is the power or index, this is the power or index, or whatsoever written here will be called as coefficient. When there is no coefficient written, then it means that 1 is written over here. So my dear students, always remember that 1x raised to power n means that 1 is the coefficient. If it is not written, I have intentionally wrote it little dim. It is coefficient, coefficient. Now this is base and this is power or index, or index, and in this book we'll say it index, not power. Though these words, all these words are interchangeably used. These words can be interchangeably used. Now my dear students, this was the first law. Let me proceed towards the second law. And the second law is dividing the same way, dividing the same base number with different indices or with the same index. Dividing first was concerned with multiplication, now dividing the same base. Now bases are same but with different indices, or I can say with same index. I'll tell you one example of that as well, and that is but with different weight and with same base, with same index with same index. Now any could happen over here. You divide the same base with different indices, or you divide the same base with same index. Okay, now let me explain it to you. Now if we have x5 written over here, and which is divided by x3. Now there are two ways of solving this question, and that is x multiplied by x multiplied by x multiplied by x multiplied by x. You have written the x for 5 times, 1 2 3 4 5 and 9, and x multiplied x multiplied x. Now what will happen? You will give it a cancelling effect. Cancel this, and what will become? It will become as x square. Now you see the leftover are only two same bases with power 1 each. Now what will happen? It will become x square according to the first law of multiplication of indices. But the second way, which is more concerned about the indices rule, and that is, if the same thing is written over here, x5 divided by x3, what will you do? You will just bring this denominator, or I can say, or let me stay here for or. Let me solve it first. This one, x5 will bring this in the numerator as well, x minus 3. When you bring, when you shift this x into numerator, the only thing which will happen will to the power, and the sign of the power will be changed. The sign of the power will be changed. If it was negative, it will become positive. If it is positive, it will become negative. Now you see, again the law of multiplication will apply here. Now what will happen? X 5 plus minus 3. X 5 minus 3, it will become as 5 minus 3. Simple. 5 minus 3, it will become 2. Now I told you or. What is or over here? Now or is here that if the situation is like this, x3 divided by x5. Now you see that there is, you are allowed to go here from denominator to numerator, or it will be easier if you let it remain like this and you do it like this: 1 divided by x 5 and x minus 3. Now you see When the position has been shifted, the sign has been changed. So here again, the outcome will be 1 upon x square. You follow but my point? Now let's proceed. If there is another law, yes, I wrote here with the same base and with these different indices or with the same index. Now that was in fact, now this is the with different indices, and the third rule is with the same index. Now dividing the same base, now this is rule number 3, with same base with same index number. Now dear students, let me write the previous one in the general term as well. I forget to write it in the general term. Now if it is written like this, x m divided by x n. Now this is the general term for previous and this one as well. It will be written as x m minus n, f x m minus n, and we have also done it like this. It can also be written as x1 divided by x n minus m, as per requirement, but just focus on this. Now with the same index like this, if it is x cube divided by x cube, now what will happen, we'll write it x x x x x x. You see what will happen over here? A cancellation effect. Tuck 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 tuck. And what will be the outcome? That will be 1. Okay. Now what has happened over here? Then that m and n bears the same name, same number. So if m and n are same, like this, we'll write this as x3 minus 3. It is x0, and I have told you many times that anything raised to power 0, anything raised to power 0 is 1. Remember this thing. Even if it is written many zeros, with many zeros, and it is also raised to power 0, it is 1. Many zeros, there are many unlimited zeros, then it will also be equal to 1. By virtue of this, by virtue. So let's proceed to the final law. Now index with raising. Now this may, I think the this fourth law, and it is raising the power. This is P, okay? Raising the power. Now dear students, fourth and final law is raising the power. What is raising the power? Raising the power means that if you have an x which is superscripted by power 2 or index 2 and again with power 3, what does it mean? It means, in short, I tell you first in short, then I'll show you the details. X, when this situation occurs with you, You just multiply this power with this power. It is very simple. Just multiply this power with the whole power. Now the inner power is 2, the outer power is 3. That means that when you will multiply, it will become 6. Uh, 2 multiplied 3 is 6. Okay? 2 multiplied 3 is 6. Now how does it has happened? Now, according to the laws, we'll solve whatsoever is written within the bracket. Now, within the bracket, it is written as x multiplied x, and here it is written 3. Now, you have already solved the element which is inside the bracket, but we still are left with the outer power. So, what does it mean? It means that we still have to solve for this power. Now, this power is also for first x and for the second x. For the first x, for the second x, this power will be utilized by both for this element, for this element. And if I open this, it will become x multiplied by x for this one, and for this one x multiplied by x multiplied by x. You see, 3x's for this element, and for this element also there are 3x's. And according to the first law, the bases are same, all the 6 bases are same. Then what will happen here, that you will write x raised to power 6. Now in the general term, let me write it like this: if x is raised to power m and then n, it will be written as x m multiplied by n, or simply you can write x m n. This is the general form of this equation, of this component. Okay. Now, dear students, this was all for today, and I am going to solve exercise 2.8 in our next lecture. We are going to skip exercise 2.7 because we will cover the 2.7 exercise in 2.8, and it will be just wastage of time if I'll waste one lecture with exercise 2.7. So all the things, all the contents of 2.7 are included in exercise 2.8. So we'll be doing exercise 2.8 in our next lecture. So it's time to say you goodbye. Allah Hafiz. Take care.